We will now program our pneumatic pusher simulator with the Click PLUS PLC. The Machine Simulator, or MS, is a valuable component of the Machine Simulator software suite. It offers a range of built-in machines including the pneumatic pusher machine, which effectively demonstrates various programming techniques. We will use the Click PLC programming software to showcase a sequencer application for this example. In this scenario, 2 boxes on a conveyor belt are pushed onto a loading dock with a pneumatic pusher. When 8 boxes are accumulated on the dock loading, a second pneumatic pusher will move them into a crate. A logical sequence of steps will be implemented, with a counter controlling the progression. This fundamental approach to programming sequences apply to all PLCs. We will use the free Click programming software and a Click PLUS PLC to program the Machine Simulator pneumatic pusher simulator. Communication between the software and the PLC will be established using Modbus TCP or Ethernet. The program sequencer offers a convenient and efficient means of controlling the automated system. We will follow the 5 program development steps to guide you. These steps will provide a clear and structured approach to programming the sequencer. With that said, let's dive in and begin our journey into the world of pneumatic pushing PLC program development. Detailed information contained in this video can be found at accautomation.ca. A link has been put in the description below. If you have not watched the other videos yet, there will be links in the description below that will start you at video 1. There will be links to the rest of the videos in the series as well. Step 1. Define the task. The first step of a Click or any PLC program development is determining what must be done. Start the Machine Simulator MS. Select the Machines button on the main page or select Machines from the main menu at the Machine Simulator window. All of the available machines will be displayed. Move your mouse over the pneumatic pusher machine. This is the machine that we will be programming. 3 items will be displayed. Click the information button on the top right of the screen. This will show you a description of the pneumatic pusher machine. Select Close. The Pneumatic Pushing Machine Simulator has a demo mode. This will allow you to watch the operation of the pneumatic pusher so that we can understand the basics of how this needs to function. Select the demo mode for the pneumatic pusher machine. When 2 boxes are collected at the end of the small conveyor, the conveyor will stop. Both capacitive sensors will be on, indicating that the boxes are present. The cylinder 1 pneumatic pusher will advance for some time or until the piston 1 advanced sensor comes on. When cylinder 1 retracts all the way, the small conveyor will start loading 2 more boxes again. When the loading dock has 8 boxes, the open cover will open. After the cover is open, cylinder 2 pneumatic pusher will advance until the piston 2 advanced sensor comes on. This ensures all the boxes are pushed into the crate. When cylinder 2 retracts all the way, the open cover will close. The cycle can then start over again. Move around this 3D environment. The icons on the top of the window will allow you to move around this 3D environment. The first icon is the default selection. This will allow you to move around without bumping into the components. The last icon will automatically show you around this virtual environment. The first person mode will mimic a person in your 3D learning world. The third person will show you an operator and a relationship to the pneumatic pusher machine. Once we understand what must be done, we can move on to the next step in developing our Click PLC program. Step 2. Define the inputs and outputs. At the top of the Pneumatic Pusher Machine Simulator window, the View I/O will display the inputs and outputs required for this example. The outputs are on the left-hand side and the inputs are on the right-hand side. While still in demo mode, you can see the operation of the inputs and outputs. The Pneumatic Pusher Machine Simulator will require 6 digital outputs and 8 digital inputs. If you are unsure of what the input or output is doing, start the Pneumatic Pusher Machine in Start mode. Select View I/O at the top middle of the Pneumatic Pusher Machine Simulator window. You can manually run the pneumatic pusher without control like a Click PLC connection. Clicking the outputs will allow you to turn them on manually. You can then monitor the inputs and see their operation. The Restart button on the top of the Pneumatic Pusher Machine Simulator window will reset the scene back to the start. The following table will define the inputs and outputs, or I/O, and Modbus addresses in the Click PLC will be used for this program. Step 3. Develop a logical sequence of operation. A flowchart or sequence table is used to understand the process that must be controlled thoroughly. It must also answer questions like this. What happens when electrical power or pneumatic air is lost? What happens when inputs and output devices fail? Do we need redundancy? This step is where you'll spend most of your time. Understanding everything about the operation will save you time. It will help prevent you from continuously rewriting your PLC program logic. Knowing all these answers up front is vital in developing the PLC program. Our Click PLC pneumatic pusher program example can be broken down into steps. Our sequence table for the pneumatic pusher will show the input signals on the left and the output signals on the right. The value of the counter is shown with each step. Each step will show the conditions that need to occur for the next step to operate. We will load 2 boxes at a time on the conveyor belt. We will load 8 boxes on the table using the first pneumatic pusher. After the cover opens, the second pneumatic pusher will push the boxes into the crate. When the pusher returns, the cover closes and the sequence starts over. A programmer must know everything about the sequence and operation of the machine before programming. Ask questions or review existing documentation to ensure you know the logical steps of the machine's operation. Step 4. Develop the Click PLC program. The next step in our program development will be writing the ladder logic code for the Click PLC example. We will use the free Click programming software with the Click PLUS PLC. The Click series will install the program, communicate the instructions, and address the controller. Using the address picker, enter as many address names as you can think of that we will use in the program. As we write the program, we can continuously document and add additional addresses. To access the address picker, select it from the main menu, Program Address Picker. This can also be accessed in the navigation window in the Program tab under the Ladder Program heading. The first rung will control the start-stop bit for the sequencer. This is an internal bit C1. This bit will be used as a condition in the entire program. A counter is used as the primary control for the steps in the sequencer. We compare the steps and input conditions that will move the program to the next step. The reset of our sequencer, or counter, will come from the first scan of the PLC or when step 13 of our program has happened. Our start-stop bit and the sequence number will control the outputs for our program. Conditions for the PLC outputs can be placed on this rung. For the conveyor to be turned on, piston 1 must be back. Cylinder 1 control advanced output must also have a timer. This is because the cylinder may not extend when multiple boxes are on the table, so the extend sensor may not signal. We also may require a quick 500 millisecond timer to ensure separation in the advance and return signals within the sequence. Sequence numbers will determine when outputs will activate as we go through all the physical outputs. The advantage of using a counter as the control for the sequencer is that when we program, we can test our logic. This is the end of the ladder logic for a pneumatic pusher program. Select the COM port under the Setup selection on the main menu. The available ports on the Click PLC are displayed. Using Modbus TCP Ethernet, we can set up either the WLAN wireless local network or the port 1 Ethernet. Select Setup for port 1. If you want to go directly to the COM port Setup Details window, select COM port 1 Setup under the CPU configuration of the Function tab on your navigation window. A static IP address will be used for our Click PLC. This ensures the IP address on a network can always be found. Note that the IP address we are using. This will be used later for a pneumatic pusher machine simulation connection. Under the Setup menu on the main screen, we will also see Modbus TCP. This will show us the default parameters for our Ethernet port and allow us to enable the Modbus TCP server. This is enabled by default on the controller. We will leave everything as its default values. Our Click PLC Plus is now set to communicate to our Machine Simulator Modbus TCP server. Download the Click Ladder Logic program to the Click PLUS PLC. Ensure that the PLC is in run mode. If you're enjoying this video, please hit the like button below. Keeping up with all the latest automation innovations can be difficult, so hit the subscribe button. Remember to click the bell beside your subscription to actually receive those notifications. Step 5. Test the program. We will now use Modbus TCP on our Click PLUS PLC to communicate with the Machine Simulator. Call up the Pneumatic Pusher Machine Simulator in Start mode. The status of the Machine Simulator will be at the bottom left corner of the screen. Currently we have no PLC connected. Select I/O drivers on the top of the screen. The Machine Simulator I/O number will be displayed. Ensure we select more I/O than required for a pneumatic pusher machine. The EasyPLC driver is selected by default. Under the driver pull-down menu, select Modbus driver. This driver will communicate Modbus TCP Ethernet and Modbus RTU serial. Select the down arrow on the driver's name. Select the Configure button. We can now enter the information of our Modbus driver. Select TCP IP. This means the Ethernet port on our computer will communicate with the Click PLC. The digital inputs from MS to the Click PLC will be C101 to C106. This will start at address 16484 due to the offset of 1. Digital outputs from MS to the Click PLC will be C201 to C208. This will begin at address 16584 due to the offset of 1. Select the OK button. You will now see the inputs and outputs specified for our Modbus driver. We can manually assign the driver outputs to the PLC inputs and the driver inputs to the PLC outputs. However, the automatic assignment works well and will save you time. Select Automatic Assignment from the driver option in the main menu. This will automatically assign the PLC I/O to the Machine Simulator I/O. Select Start Driver and exit from the main menu. At the bottom left side of the window, the driver communicates with the Click PLUS PLC. Select View I/O to know the input and output status of the Machine Simulator. Ensure that the Click PLC is in run mode. We can see the operation of our pneumatic pusher machine. please select the first switch on your Click PLC to start the sequencer. The digital inputs and outputs of the MS will correspond to the PLC controller. Using the data view window of the Click programming software, we can watch the inputs and outputs operate. Using a machine simulator MS to test the program will ensure that our program works. Troubleshooting is quickly done without damage to any physical hardware. You can practice your modification and debug by modifying pneumatic pusher operation in the following ways. Add a start-stop control panel to the machine. Add a jog button to the control panel to sequence through the steps. Calculate the rate of the pneumatic pushers per hour. This can be used later on to create a maintenance program. Let me know how you made out in the comments below. To learn more about using 5 steps to PLC program development, click here. Click here to learn more about the PLC and Node-RED.